different, man. Something's different.
Nah, man. It's back again. Another episode of a Muslim and Atheist Breaks Bread. What you saying, Pat?
I'm good, man.
You good?
I just hit the wave.
Just stop. God damn. So yeah. Okay, so obviously, like I said, we do a lot of videos on religion. Trying to unpack it. But there's the other side of that, there is the science. So I feel like we did a Richard Dawkins video not long ago and it stimulated some good conversation. So I thought we'd dive into this, as I know you're a non-believer of evolution. Yeah? So you don't believe in evolution.
I don't believe in Darwin.
You don't believe in Darwin's theory. And you think that it has had no relevant impact on the earth.
Well,
or on the world as we know it.
You show me where.
So,
you know,
we're going to
I'm
watch.
to learning.
Yeah, man. Alright then. So, today we're going to watch Richard Dawkins Explains Evolution and Natural Selection.
If you wanted to do an experiment to test the theory of natural selection, what would you do? Well, experiment implies human intervention. What you would do would be to administer the selective force yourself as an experimenter. In other words, you would do artificial selection, which is what humans have done inadvertently at first in breeding dogs and cabbages and pigeons and so on. And also experimentally, there are now numerous experiments where people have administered a selective pressure on populations of animals and plants and produced dramatic results, dramatic evolutionary change in a very short time, within one human lifetime. A nice example is the work of Belayev, a Russian geneticist who studied silver foxes and bred them artificially for tameness. And he succeeded in breeding super tame foxes, which behaved like dogs, licked your face, wagged their tail, behaved just like dogs. What's more interesting is that after only about 30 years, he has these foxes that look like dogs. They look like collie dogs, no longer look like foxes. They've got black and white patches on their coats. They've got floppy ears. They bark like dogs. That is a curious phenomenon of traits being dragged along in the wake of other ones. He selected only for tameness, but what he got was dog-like characteristics in all sorts of other respects. That's an interesting side glance. The important point is that he produced dramatic evolutionary change in a mere 30 years. And if you can do that in 30 years, just think what could be achieved in 100 million years. It would not be artificial selection, of course, it would be natural selection.
What was dramatic about that?
What do you mean?
He said he'd achieved dramatic change in only 30 years. If
to change a whole dog's characteristics. Not even a dog, a fox. To get a fox to think it's a dog, or to behave, or to drive that change within it, or its offspring. I would assume it would have been its offspring really that changed, but what do you mean?
What's dramatic about that? Wasn't it still a fox?
But no one's saying it's dramatic. They're just saying it shows.
He said it was
evolution.
dramatic. He said dramatic change in 30 years, and I said, well, wasn't it still a fox?
Yeah, I see what you're saying, but I think like you're oversimplifying it. It was still a fox, yeah.
Its
But
behaviour
its
changed.
characteristics,
Its
yeah.
behaviour changed.
Mm-hmm.
But have you heard the slave trade?
Yeah.
Think on it. Carry on.
Natural selection. Coming on to that, we've moved now up the primrose path of seduction from artificial selection, which anybody can understand, and which was understood, of course, long before Darwin, to natural selection, which only Darwin and Wallace, it could be argued anyway, really grasped. It was Darwin and Wallace who saw the principle of artificial selection that everybody understood could be generalized to nature. Nature just means that some animals survive and some animals don't survive, for whatever reason. And that has exactly the same effect as if there was a human breeder choosing which puppies to save and which puppies to kill, which puppies to breed from, which puppies not to breed from. In order to get major macroevolutionary change, such as changing fish into mammals, you need time. Artificial selection, we've seen that in human terms in a few centuries, we've seen what can be done, but in natural selection, evolution, we've got hundreds of millions of years. We need to know how, we need to set out the evidence that we do have hundreds of millions of years. In Darwin's time, this was doubted. Chapter 6, missing link. What do you mean, missing? Creationists love the fossil record because they think it's an embarrassment to evolutionists because they point out that there are gaps in the fossil record. Well, of course there are gaps in the fossil record. What do you expect? Would you expect every single species that's ever lived to fossilize? We're lucky to have fossils at all. If we didn't have a single fossil, if not a single corpse had ever fossilized, the evidence for evolution would be utterly secure. We don't need fossils to demonstrate evolution. It's nice that we've got them because they tell us a lot about the history of life, but we don't need them to demonstrate that evolution is a fact. The evidence comes from other sources. I'm going to read another short passage from this chapter. What would be evidence against evolution, and very strong evidence at that, would be the discovery of even a single fossil in the wrong geological stratum. J.B.S. Haldane famously retorted when asked to name an observation that would disprove the theory of evolution, "Fossil rabbits in the Precambrian." No such rabbits, no authentically anachronistic fossils of any kind have ever been found. All the fossils that we have, and there are very, very many indeed, occur without a single authenticated exception in the right temporal sequence. Yes, there are gaps where there are no fossils at all, and that's only to be expected. But not a single solitary fossil has ever been found before it could have evolved. That's a very telling fact, and there's no reason why we should expect it on the creationist theory. A good theory, a scientific theory, is one that is vulnerable to disproof, yet is not disproved. Evolution could so easily be disproved if just a single fossil turned up in the wrong date order. Evolution has passed this test with flying colours. Skeptics of evolution who wish to prove their case should be diligently scrabbling around in the rocks, desperately trying to find anachronistic fossils. Maybe they'll find one. Want a bet? The next chapter carries on the theme of fossils into human fossils. It's called Missing Persons, Missing No Longer. And I'm going to read just a little bit about the type specimen of Australopithecus africanus, which is the so-called tawny child. Australopithecus was the genus that almost certainly preceded our own genus Homo in our evolutionary ancestry. In other words, we're almost certainly descended from members of the genus Australopithecus, although it may not be any one of the species that have so far been named. The first Australopithecine to be discovered, and the type specimen of the genus, was the so-called tawny child. At the age of 3.5, the tawny child was eaten by an eagle. The evidence is that damage marks to the eye sockets of the fossil are identical to marks. I want at this point to raise a point of terminology which I think is extremely relevant. The tawny child, I said, was the type specimen of Australopithecus africanus. That means it's the specimen that was first discovered and described and to which people refer when they have a new specimen and they want to know, does it belong to this species or not? So each new fossil or new animal indeed that's discovered is always given a Linnaean binomial name, a specific name preceded by a generic name like Homo sapiens, Australopithecus africanus, or whatever it is. When a fossil is actually intermediate between two species or two genera, and on the evolutionary view there must be such fossils, we are not allowed by our conventions of nomenclature to give it an intermediate name. There's no machinery in language to give a name that is intermediate between, say, Australopithecus afarensis and Homo habilis. Yet, if there must have been a member of the genus Homo that was the immediate child of a member of the genus Australopithecus, but you can immediately see that that's nonsense, because how could a baby be a different genus from its mother? Obviously, in every single case, every baby born is the same species, let alone the same genus, as its mother. If you were to walk backwards down through your ancestral tree, starting with your mother, and then your grandmother, great-grandmother, let's just stick to females for convenience, great-great-grandmother, and so on, you would go back and back and back and back and back, go back as far as you like, and gradually the animals that you were walking past, as you walk past your ancestors, would be gradually, ever so slowly changing into something else. By the time you got back to about 6 or 7 million years ago, you would be looking at an animal which was the common ancestor between ourselves and chimpanzees. And you could then, if you wish, turn around and start walking forwards along the line leading to chimpanzees. At every single point along that sequence, the animals that you are looking at would belong to the same species as their immediate neighbors, which would be their mother and their daughter. They would be more alike than members of species ordinarily are, because they would be mother and daughter, therefore they would be more alike. And yet, if you walk back sufficiently far, they would have changed from modern Homo sapiens to a completely different genus. You could go back to a fish using the same technique. And by the time you got to the end of your walk, you would have walked through a continuously changing set of animals, all the way from human to fish, and then you could walk forwards again from fish to, I don't know what, I mean a kangaroo or something. In every single case, you would be seeing animals that are of the same species as their neighbors in the sequence, and yet the changes are so slow, but yet so persistent, that eventually you'd get back to a fish. It's not all that surprising, because after all, when a baby turns into an adult, you don't suddenly say, aha, it ceased to be a baby, it's now turned into a child. And then, aha, it ceased to be a child, it's now become an adult. It happens so gradually, you don't notice the change. We're like a flea sitting on the hour hand of a watch. You can't see it moving. It moves so slowly that you don't see it. Now, the hand of a man and the wing of a bat are directly homologous. A bat's wing is enormously long, splayed out fingers with webbing stretched between the fingers. A horse's hoof is the same hand where, of the 5 fingers, only the middle one remains, and the horse walks on the middle finger and the middle toe, and the hoof is the nail. And you can see that, you can see it in the fossil record, how the number of fingers diminished, and there are occasional freak horses which are born with 3 toes, showing an intermediate stage. But that was the limit of what was possible in Darwin's time. You could compare anatomy and show very, very convincingly that it fell on a family tree. Nowadays you can do the same thing with molecules, with genes molecularly analyzed. And the sheer amount of information available is multiplied many orders of magnitude. Because the genetic code is universal, all creatures have the same machine code, the same code whereby triplets of DNA are rendered into amino acids. You can directly compare the same gene in one animal with the same gene in another animal. You know it's the same gene. It's got essentially the same sequence with minor differences. There's a letter different here, a letter different there, a letter different there. And the corresponding differences appear in the amino acids and in the protein chain that they produce. But you can say this is the same gene, it's doing the same job, it's got the same sequence with these minor differences. And then you can literally count the number of differences between these genes. It's not a case of saying, oh, this limb looks a bit like that limb. You are literally comparing alternative texts, just like alternative versions of the book of Isaiah or something, where you just count the number of differences that there are between chapters, between letters, between sentences, words. And when you do that, for any one gene you like, you find that the differences fall on a beautiful hierarchical tree. What could that be but a family tree? What could that be but a pedigree? Then you do the same thing for another gene, and you find the same tree. And then you do it for another gene, and you find the same tree. Then you do it for a gene which no longer does anything, but you can still sequence it. Nature doesn't read the gene anymore. It's never translated into protein. But molecular geneticists can read it, and they can recognize that it is a defunct version of the same gene. And again, when you compare these pseudogenes, you find the same family tree.
What do you think so far?
I'm waiting for him to say anything at all that makes any sense. He said, if we walk far enough back, okay, great idea. You know, we've been here a long time. Lots of people been here to witness, you know, what their great-grandma looked like. And none of them saw them look different.
Yeah, but we're talking about over 1 million years.
Yeah, that's what I said.
You can't think of it like, yeah, but I've seen my great-grandma.
Well, it's a great theory. Over 1 million years, you know, we came from, like you said, a petri dish all the way through to this. That don't make no sense.
Why?
Because then everything in existence would be just along that same journey, and so the man.
That's the point. That's what he's saying. So every single thing on this planet came from the same thing.
Yeah,
so
but if we stay here for another 1 million years, we're gonna be people. We're not gonna be a next level something unless someone alters that.
How do you know that? You would never know that. 1 million years. Think about how long you're alive for.
I can look back a few thousand years and they look like people to me. I can go all the way back 4,000 on pyramid walls where they drew people. They look like people to me.
That's 4,000 years. That's nowhere near.
Well,
1.5 million, 4,000
that's as far as I'm able to confess to. You know, beyond that, then I have to speculate. So clearly there was a starting point for me.
Mm-hmm.
I don't believe in the evolving into something else. You know, is there everything made out of a certain, you know,
molecule, yeah,
molecules and stuff. Everything's made out of that for life. But that doesn't mean that, like I said, the base code for a man is the base code for a man. The base code for a fish is the base code for a fish.
Yeah, but that's because at some point in that evolutionary line,
mm-hmm.
from the thing, the base code got changed, didn't it? So something happened, something triggered it changing. So like he said, it's the same way. You know, if you go backwards, and I get what you're saying, he's telling you something, but it's not. There's no evidence in what he's saying. It sounds good. I can get that point. But what he's saying is that if you do walk backwards, there's going to be a point where if you start walking forwards again, you're going to be something else. So we can go back to Australopithecus, which was the first. What they're trying to say is like half ape, half man.
No, what the Darwinists are trying to say.
But what they're trying to say, that's what it is.
You get me? So, but again, I
But
don't
if you
believe in
walk
that.
further back, you can go to a point where you're going to turn into a kangaroo.
So he says.
Same line.
So the Darwinists say, but I believe that man was made as a man and it didn't evolve into anything at any other point.
Mm-hmm.
Man may have, you know, the evidence to me looks like there were people here who were intelligent before and something happened
Mm-hmm.
and they disappeared and now people have got smart again. That's the evidence.
Well, people have got smarter now.
Yeah, smart again.
Okay.
Not smarter, smart again, because the people who, you know, did the things that they don't talk about,
Mm-hmm.
that we all know exist and stuff, they were clearly smart.
Yeah, definitely.
So they're not around, or a lot of evidence isn't left of them. Maybe one or two of them is around that's brought society forward into smartness again. But smartness then led to some sort of destruction, and the way people behave now, smartness is taking us way to paradise or to destruction.
Okay. Right, let's finish this.
Family tree. There are minor exceptions to that, but in general, it's dramatically true that if you look at different genes, you find they fall on the same tree. What could that tree be but a family tree? The only alternative is that the intelligent designer, the creator, deliberately set out to deceive us and make it look as though evolution had happened when it didn't. That's not a resort that I think many theists would wish to cling to.
Read. Looking back at the point of bifurcation in the development of new species, all the species that are defined as species lose the ability to interbreed. So is there some sort of a common process in all of life that says once you reach a certain point, you can't interbreed anymore?
Yes, it happens. It happens at first when the chromosomes of the two. If you take a hybrid, like say a hybrid between a donkey and a horse, a mule or a hinny, the chromosome, the genes can still work to produce an animal, and a mule is a perfectly strong and fit animal. But when it comes to make sperms or eggs, the chromosomes need to come together in order to perform the process of meiosis. And if there's a sufficient difference between the chromosomes, as there is between horses and donkeys, then the chromosomes can't come together in meiosis, and so the animal cannot make gametes. It can't make viable sperms or eggs. That's the first thing that happens. The later thing that happens is that the animals don't even want to mate with each other because they look too different or smell too different. So it is a gradual process. It doesn't, there's a sudden curtain comes down. It says, right, you're now a separate species, you can't interbreed. What happens is it's usually in geographical isolation. The ancestors of horses and donkeys would have been split by some kind of geographical barrier, and they would have drifted apart, or maybe been selected apart, sufficiently far that when they met again, they either didn't want to breed again or couldn't breed again, interbreed again, and that's the point where biologists come along and say, okay, they're now a different species. It is a gradual process, but once it's happened, it's never reversed. I think
Stop
Thank
there.
you very much, Dr. Dawkins.
So, something with the horse now, like I said, the whole horse thing. Europeans brought horses to America, right? So,
It's a theory.
no, Europeans brought horses to America,
Okay.
right? So, the Europeans brought horses there. So, horses were in Europe. So, donkeys must have started in Europe, according to what he's saying. Then, mules, where someone got the idea of breeding a donkey and a horse. He said someone intervened and they created a mule, which is a perfectly strong animal. It just can't replicate itself.
Yeah.
Right. So this is what me say. So they would understand that because they've done that. But it was effectively, is a donkey and a horse the same? Because they can breed, create a mule. The assumption is that there's similarities, but that don't mean that they're the same.
What do you mean? That's what
That
he's
there's
saying.
no,
They're
well,
not the
there's
same.
no proof. No, he said they are the same because they're the same family. They're breedable.
No. Yeah. But the new species.
Yeah, the
that's what he's
evolved
saying.
species in isolation are
Yeah,
sufficiently different that they're not interested in each other.
Yeah.
But, again, he makes the assumption that a donkey and a horse is the same species. He makes the assumption. Because where did horses and donkeys come from and start from? We know where they started in America, but we don't know where they started in Europe, or was it, on the plains of Russia? They got different horses around the world, and these Europeans have been utilizing them since back in the day. And the Ottomans and the Genghis Khan, they came in on some horse and have all sorts of fancy tricks and have special kinds of horses that perform things. So the knowledge of horse breeding has been around for a while. the donkey and the mule thing, when did that start and who started that? And he's saying it's a man who started. That would be more interesting to me than just presenting the premise that a donkey used to be a horse. Where's the evidence for that? You understand? He should have proved that and then said, and then we bred a mule. Mule not have no use. You understand? Mule.
But they know from that mule, from doing like tests on it, like genetic tests, so they'll be able to tell. You know, like they can map genes, so they'll be able to tell whether that mule is half donkey and half horse. And
Well, they know it is because they did it.
yeah, so that's what I'm saying.
So they know the parents, but they can't be any kids. So
And that's what
it's a functionless exercise, which is why they're not interested in each other. Which to me would suggest they're not the same species, rather than they used to be the same species. You know, a black man and a white woman, for example, same species, right? They're interested in each other because it's compatible and they have kids and it's still the same species. A donkey and a mule, a donkey and a horse are two different species, in my opinion. That's why they're not interested in each other.
That's what I thought he said. I thought a
No,
donkey.
he's saying that.
Sorry,
yeah,
I thought he said a donkey
effectively they
and a
came from
horse.
the same place. They're
I
in
would-
different environments, developed different. So, but it was the same species. I'm saying, who said that? Prove that. Yeah, they did come from different environments. One
But I think they would be able to
started
prove
messing
that
about
through
with them.
genetics. I think they would be able to prove that. Anyway, okay, so yeah, I'll be honest with you. I didn't think that was the best video. Yeah, I guess.
It's just theoring, maybe, but maybe, yeah, you know. Didn't prove anything. I'm still a creationist.
Well, we're not. I don't think we're trying to get you to change, to be honest. But you
And
know,
I'm listening to the argument, Mr. Dawkins. It's a nice theory, but
I don't think that was his best.
maybe he doesn't feel like a man, so he's struggling with something else and trying to put it in something else.
What do you mean? What does that mean?
Well, like
Why
I said,
would his
I feel
science-
like a man, and I want my kids to feel like men if they're boys and like women if they're girls. And it
Yeah,
for
well,
him,
what's-
like I said, maybe he feels like he was a fish. So in his mind, he's looking for something in science to justify and explain that feeling to him. You know,
What's a rhinoplasty? Oh, that's hilarious. Okay, yeah, so anyway, that was Richard Dawkins explains evolution and natural selection. We out. Peace.
peace.